This
Okay,
conference will now
so
be recorded.
good morning all and welcome back to the session. This is Big Data Masters program. Currently we are going through with distributed processing with PySpark. So far from the PySpark perspective, what we have seen distributed processing with PySpark. So we have seen the stuff. Like I'm going to uh, provide you an overview what we have covered so far. So we have started our journey with big data, like what is big data, and then we have identified the challenges with big data, and those challenges was processing and storage. Okay, so we need a particular solution with the help of what we will be able to store the data, and until unless we are not able to process that particular stored data, that is not making any sense. So what is big data, challenges with big data, these particular things we have covered. Then we have seen like distributed computing. What is distributed computing? Distributed computing. Okay, so from the distributed computing, what we have seen, instead of leveraging one machine to process huge amount of data, we are leveraging multiple machines. We are going to utilize multiple machines together, multiple machines utilized to process data. Okay, so we have seen this particular aspect as well. Then we have seen like Google has published certain white papers, and based upon those particular white papers, a particular solution, Hadoop was built, and that was nothing but a form of distributed computing. Hadoop is a form of distributed computing only. Over here, we are having multiple machine in terms of master and slave, and these particular machines are working in order to solve a particular problem. So we have gone through with what is Hadoop and its component, and its component and architecture. And over there, what we have understood like MapReduce and HDFS. And the third component was RM. That is nothing but the resource manager. Then what we have seen like Hadoop was having certain limitation. So a limitation of Hadoop, like it was having long running jobs, and these particular jobs are working onto a methodology like MapReduce for the processing perspective, and this is disk processing system. So because of this processing system, the jobs over here are having high latency. So we have gone through with those particular limitations. Another limitation, like if you need to perform hundred of the things like ingestion, processing, analysis, data exploration, curing the data which is stored inside the HDFS. So you need to learn hundred of the things. Hundred of the things means there is no one way of coding. We need to have different. We need to learn different ways of coding in order to work with Hadoop. So the researchers were looking for a particular solution, and with respect to like the problems which was faced inside the Hadoop. And they identified like Spark is the solution for that. I'm trying to connect the dots basically, like what we have covered so far. What is the meaning of that? Then we have started Spark, and from the Spark side, what we are able to know, Spark is in memory general purpose compute engine. Whatever we are processing with the help of Spark, that is processed inside the memory. So it is like this, say HDFS, or you can say storage, Then what we are having say compute engine, and we are having say resource manager, resource manager. So over here, say once we are having Hadoop, so this was look like say is we are having say HDFS in terms of storage, and with respect to compute engine we are having MapReduce, and with respect to resource manager we are having YANA, yet another resource navigator. But once we are talking about say Spark, Spark, inside Spark what we are having, we are just replace this particular compute engine. uh, Let me decrease it a little bit. So we have just replaced this particular compute engine to Spark, and then we are able to process our application with low latency, which was taking huge time, almost like 100 times more than Spark inside the Hadoop. Hadoop was taking 100 times more time if we compare it with Spark. So the latency issue, the challenge what was there in Hadoop, it has been resolved. And Spark is saying what? Give me the storage of your choice, give me the resource manager of your choice, and just replace the compute engine which you are having inside the Hadoop ecosystem, and I will be able to perform in a better way. So this is the methodology like how Spark was working. Okay. Then we have started our Spark journey. Then we have gone through with Spark RDDs. Okay. And from the Spark RDDs, what we have covered like how to create RDDs. Create RDDs. RDDs are nothing but resilient distributed data set. So how to create RDDs, and we have seen like there are different ways, say with parallelize function, then with another RDD, and third method like once we apply transformation on RDD. So that will give a RDD. Okay, if we are applying a transformation on a RDD, then result will be another RDD. RDDs are immutable objects, distributed collection of objects inside the memory. So we have then applied, you can say, we have gone through with different transformations and actions from the RDD side, and we have uh, understood like how to work with RDDs. Then what we have started Spark data frame, Spark data frame, and from the Spark data frame perspective, what we have seen how to say how to deal with columns. Okay, like creation of new column or selecting a particular column. Okay, then group by, then order by, then sort. Okay, aggregation, joins, then cache and persist, broadcasting, broadcasting, then coalesce and repartition, and partition by bucket by. Okay, so these particular things we have seen from the Spark side, and if in short, if like I want to explain this, like we have gone through with optimization. Optimization, like it is of two types: application level, and number two resource level. source level optimization. So once we are talking about application level optimization, so with respect to application level optimization, we are going to uh, work with different optimization techniques. We are going to apply different optimization technique onto top of a particular data, and then we will be able to minimize the latency. Then second one is resource level optimization. Over here we are dealing with resources, say number of executors, number of executors, executor core, executor memory. Okay, our main agenda is to check like, do we have enough resources in order to execute this particular job? And application level optimization is nothing but say code level optimization. Change in code to achieve performance. To achieve performance. Achieving performance means like minimizing the latency of a particular job. So these particular things we have seen from the Spark data frame side. And like we are taking a particular data frame, and then what we are going to do, we are going to apply certain functions in order to do the aggregations, or like in order to do the processing onto top of a particular data frame, and finally like we are going to write it onto the disk. So from the data frame perspective, like there are two main other aspects what we have learned, like read API and write API. Write API. Okay. So first one is read and second one is write. Last one is write. In the middle part, what we are doing the processing. These all particular things are with respect to the processing of a particular data frame in order to get a particular outcome. So these particular things we have seen, we have learned in detail. There are certain topics which like I need to cover, like window functions and accumulation. Those particular topics will not take much time, but I will cover those particular things. Another stuff what we have covered, Spark SQL. Spark SQL. With respect to SparkSQL, what we guys are going to do, like we are going to create a temp view, creation of a temp view on a data frame, and then what we are going to do, based upon the SQL queries we are processing. So reading and writing, both of these two things are happening over here with respect to Spark, you can say data frame, read API, reading with say reading with data frame, and writing with data frames. In the middle, like what we are going to do, we are going to create a temp view over here, and after creation of temp view, all of these particular functions, the processing layer is done with SQL queries. So that's the beauty of Spark SQL. This is, you can say, higher order API from the Spark side, or this is inside the Spark ecosystem. And with the help of this, we will be able to process our data with SQL queries. And we have gone through with this particular aspect as well. Okay, all of the things which we have learned over here in data frames, say a persist, broadcast, coalesce, repartition, partition, those particular things we can apply over here as well, with the help of Spark SQL. Okay, So that's what we have learned so far with our learning journey. In the last session, say I have shown like how to create a Databricks account, then how to create a Databricks account. Okay, so these particular things we have learned so far from the Spark side. Now, I want to show you something. There is one more topic, which is or one more you can say processing framework, uh, which we have not covered from the Spark side. So Spark RDD, Dataframe, and SparkSQL. So far, what we have learned with respect to batch processing. Batch processing. So, batch processing, what is the meaning of this? Say we are having a particular source. In that particular source, what we are having, say we are performing ingestion. Say source is there, and then we are performing ingestion. And after ingestion, what we are doing, we are putting the data into data storage, and from data storage we are moving it to for processing perspective, and from processing we are like sharing the outcome, sharing final result, sharing final output. Okay, so font wrap I need to cancel, sharing final output. So this is nothing but a simple data pipeline which we are having over here. We are performing the ingestion, then moving that particular data into data storage, then we are going to process it, and after processing, like we are sharing the output. This particular data pipeline is working onto the batch processing. Like over here, what we can have from the source side, source is not continuously generating the data. We are not having continuous streams of the data, and it is in batch format. Say at 9 a.m., the say what we are having over here, we are having a particular, so we are having a particular uh, automation tool, workflow automation tool, that is a airflow basically. Let me mention over here, airflow. Okay, and with the help of airflow, this entire pipeline is automated. So, say from the source side, we can have like event triggered or time triggered API. Yeah. Like if the data is available, you just taken an example, like we are having data inside S3, and in S3, what I can say, like the data is being ingested after some time, like at hourly basis. Like those who are working in telecom domain, they are having this particular knowledge or understanding. Say at every hour, like we are having certain files automatically generated uh, based upon the counters which has been captured in last 1 hour, and then that particular file is ingested into a data storage. From that particular data storage, it is moved to processing part, then processed, and then say probably we are getting the outcome in terms of KPI. You can think in this particular way, like like say we are having 18,000 counters, 18K counters. of say big bazaar. Say we are having 18,000 counters of big bazaar throughout the India. Okay. Now, what is happening, say, on daily basis, from all 18K counters of Big Bazaar, uh, a file is generated and a file is placed inside one server, and then from there ingestion is being happening, and those particular files are moved inside the data storage of our spark cluster, spark cluster basically, and then processing will be done on to top of that, and we will be able to get like what is the sale of yesterday. So batch processing is always having certain latency. It may be say 1 hour, it may be 24 hours, it may be 1 week, it may be 1 year. Latency is there, definitely latency is there in batch processing environment, in batch processing framework. But uh, Spark is having streaming processing as well, streaming processing. Okay. So with respect to streaming processing, uh, you can think in this particular way, like 18,000 counters or outlets of Big Bazaar are continuously generating data. Live streams of data is there. Live streams of data is there, and that particular data is being captured, and then ingestion will happen, and then that those particular, you can say, data is given to Spark streaming, and then processing will happen on the top of this, that is say processing, and then finally we will be able to get the output. So over here, this is live streams of data, live streams of data. And over here, what we are doing, micro batches. So uh, we are getting the live streams of data. So previous example, once we were having batch processing, like we are having latency. Okay. We are not having the information like what has happened in last 1 minute. Okay, that particular data was not available, that particular stats were not available inside the batch processing environment. But once we are dealing with streaming data processing, we will be having say what has happened in last 1 minute onto these particular counters, 18K counter, or what is the sale of last 18 minute or last 1 minute from these 18,000 counter, or what is the cumulative sale of Big Bazaar in last 1 minute, or what which counter is having highest sale, or which counter has generated most profit in last 30 minutes. So those particular, you can say, calculations are quite possible with the help of Spark streaming. You can think in this particular way, like right now, uh, inside the Anantnag, like there are certain terrorists, and like uh, the battle is going on among, you can say, Indian army and those particular terrorists. So there are certain tweets onto the Twitter with respect to the incident in Anantnag. Like, say, what I can say, might be Pakistan is promoting that particular incident, and over there inside the Twitter account, like the which are having say Twitter users from the Pakistan, probably providing positive feedback, positive, you can say, comment, it is happened in a good way or whatever. So uh, there, like, we can check like what is which country is having, you can say, positive or negative feedback about that particular incident, and we can have live stats for that particular incident. You can think in this particular way, like say G20 meeting was there in India in last week. So it was like the entire world was, you can say, promoting that particular incident, but inside Pakistan and China, their news channel was not in favor of uh, G20 meeting, and they are like saying that it will be unsuccessful event. So how we are able to get these particular analysis? So with the help of live streams of data, we are going to process all of those particular live feeds, and based upon the analysis, we are able to get the outcome, like what is the meaning, is it positive or negative, or what is the impact of this. Nowadays what is being happening, say, uh, if a if a minister is like uh, having certain conversation, then the media persons are going to record that particular conversation, and then they do the analysis on to top of that particular conversation. So what they are able to get, like this particular minister has used say India word 5 times, Pakistan word 10 times, terrorism 18 times. So how they are able to get like these with the help of live feeds? And this particular analysis is not like say they are recording and then performing the analysis. No, they are like just having the continuous feed, and based upon the continuous feed or live feed, they are performing that particular analysis. We will be going through with certain programs from the Spark streaming side, and where we will be going to do the analysis, say if we are having continuous feed, and how the analysis is being happening. So we will be able to do that particular analysis with the help of live feeds. We will be going through with that particular with those particular programs. No need to worry. But the main crux, or the main thing what I want to say, inside the Spark world, if we are having a live feed of data, then what we are going to do, we are doing the ingestion, we are capturing those particular live feeds, then we are going to convert those particular live feeds in micro batches. Okay, and then with the help of Spark streaming, we are processing, and we will be able to get the data. So over here, one fancy word is there, like micro batches. So what is happening with respect to micro batches? Now just try to think on that this particular way, like you are having a tap, and from the tap the water is flowing. Okay, the water is coming out from the tap, it is continuously flowing. So tap is nothing but the source of the data, and flow of water, okay, that is nothing but data. Okay, so we are getting data in terms of live feeds, say, from the tap. So if we are going to, you can say, fill a bucket from that particular water, that will take time, and until unless like we are not having the filled bucket, then we will not be able to do the analysis onto that particular bucket. So over here in the Spark world, what is being happening, we are going to capture the data in terms of micro batches. Say instead of buckets, say I'm going to fill the balloons. Now balloons are there which are being filled from the tap water, and those balloons are nothing but RDDs or data frames. Okay, RDDs or data frame. Now based upon those particular RDDs or micro batches or data frames, we are going to perform the analysis, processing, and then we will be able to get the outcome. So over here, yes, like it is something like batch processing only. It is something like batch processing only, but inside the Spark streaming, the batch size is very less. The length of batch is very less, and the processing, it might be say 1 second, 2 second, 30 second. And if like we are doing the processing every second or every 10 second, and we are able to get the outcome, then user will get the information say every 10 second or every second, and user will accommodate or think that this is real time processing. But in real, inside the PySpark, the processing is near real time. Spark streaming is near real time data processing solution. Okay. So micro batches over here, that is nothing but RDs or data frame. RDs or data frame. So based upon these particular RDs or data frame, the processing is happening and we will be able to get the outcome. Okay. And if we talk about Spark streaming processing, this is of two type. Spark streaming is of two types: stream and Spark structure streaming. Okay, stream. So once we are leveraging RDs used for processing on live streams, then we can say it is these streams. And once once data frames are used for processing on live stream, that is Spark structure streaming. Like this stream or RDD is something like the objects without schema or without any structure. And if we map a particular structure on RDD, then it will become a data frame. So that's why like it is mentioned Spark structure streaming. We have mapped a structure on RDD and it became Spark structure streaming. So the processing is being done with the help of data frames and SparkSQL. So these are the two ways with the help of what we will be able to process the live feed of data, and we will be able to get the outcome. Just have a look onto this particular stuff and ask if you are having any doubt. All of you, just have a look. Is there any issue, any doubt, any confusion, friends? Raj, Naresh, Shivam, Rahul, Swati, Rohit, any
No, sir.
confusion, whatever we have so far? Perfect, Raj. Naresh,
Yeah, sir. Little bit about micro batch, sir. Please, little explain it again.
micro batch, huh? Okay,
Yeah, yeah.
okay. I will cover. Huh? Rahul,
Well, yes, one again, like for micro batching. What else?
fine so far, huh?
Fine, fine.
Okay, okay. Perfect, huh? Shivam, Shivam,
Yes, sir. It's fine.
okay. Swati, Rohit,
So fine for me.
Yeah, it's okay. Good.
okay, okay, okay. So micro batches, huh? Let me explain micro batches. So, So what I have mentioned, say, let me try to Chrome. Micro batches, we want to get the understanding from micro batches perspective. So Spark streaming, and I just want to check certain images. Okay, so just have a look. Like over here, say we are having huge data, and in terms of, you can say, we are having a particular tab. From that particular tab, the data is flowing up. So if you want to do the analysis on to top of this particular data which is following from this particular tab, tab is nothing but the source of data, and this water like which is coming from this particular tab, this is nothing but data. Okay, now we are having this particular data that is generated, that is continuously flowing up. So if we need to do the analysis, we need to convert it into RDD or data frame, right? If we need to do the analysis, uh, Raz or Naresh, we need to capture that particular data.
Yes, sir, yes. Yes.
Okay, and inside the PySpark, what PySpark streaming or Spark streaming, that analysis is done in terms of RTD or data frame. Forgot about this stream or Spark structure streaming. Just focus on to RTDs or data frames. So what we need to do from this particular data, which is coming out from this particular data source, we need to create RTD or data frame. So this is continuous, you can say flow, and I have taken an example like if we are going to fill the balloons from this particular water or data basically, then what we will be having the RDD or data frame. Okay, so if we map the structure onto that particular data that is coming out from tab, then that will become, say, a data frame. If there is no structure, then that will remain RDD. Okay, so over here, if we are going to say fill a bucket, then we need to wait for some time. Like say bucket is taking say 2 minutes to fill, so bucket will have high latency. If we used to say like bucket is a RDD or data frame, filled bucket, like bucket with data or RDD or data frame with data, that will have high latency. If we are going to fill say a glass or say balloons, okay, then we will be do the analysis. So that means like we are splitting this incoming data into small pieces, and those small pieces are nothing but micro batches, right?
Right,
So
sir, right.
like
Noted.
say if now we are doing the analysis say on 1 second data, every second we are getting the data. Previously it was taking say we are taking 2 minutes, now we are doing the analysis on 1 second data. It is possible, that is dependent upon us, like uh, how much latency we can bear. So that we need to decide based upon the application. You might have seen say uh, you might have seen certain video or online cricket games, like ESPN. On ESPN we are getting the live feeds of cricket match, where what we are able to see, like say if a person hit the four, if a player hit the four, if a batsman hit the four, then uh, on the chat like where we are getting the live update so the chat has been updated earlier, but after some time we are able to see the live feed like he has hit the four or sometime we used to see like some say uh, inside the match like certain ads are there inside the live feed some ads are there, so we used to see onto the chat window like what has happened in last 1 minute so certain latency is there, and that is because of like the capturing that particular data and processing that particular live feed however like typing is not taking much time right? Is it fine, Naresh?
Yeah, right.
Okay, so that is with respect to say Spark streaming like micro batches are there now. Now for Spark streaming we need to have Spark streaming context Spark streaming context is required for processing streaming data. Okay, we are going with an example Spark streaming context is required in order to process streaming data. So example say we are having that, but we have gone through with that particular flights data, right? We have gone through with flight data, or let me first move with the word count program. So word count program, word count program with Spark streaming. So we need to create the Spark session. Spark. Let me type over here Spark and Spark session dot builder. Spark session dot builder. Let me open the PyCharm as well. Over here, we will be able to do it in a good way. New file. I'm going to create a new file, and then week so 14 day 22 distributed processing with PySpark. Okay, I need to import certain import. I need to import like useful libraries, PySpark .sql dot uh, PySpark .sql import Spark session. Okay, that is fine. I need to have streaming context as well from PySpark dot streaming import streaming context. Streaming context, and I'm going to import certain functions which will be utilized from PySpark.sql dot functions import split import splitter, then explode and count. I'm going to import these particular functions. Now, creation of Spark session. Spark session. So Spark equal to Spark session dot builder, and I can have app name, and I can give an app name, say streaming example. Then get or create. That is fine. Spark session has been created. Now I need to create the Spark context. So SSC, that is Spark streaming context, then streaming context, and I can give Spark context, and I can mention over here. I can mention, say I want the processing every 15 second, every 1 second, every 30 second. I can mention that particular time over here. That is fine. So I have created the Spark streaming context, and now I will be able to do my analysis. Now, input source. I need to define an input source on which I'm going to perform the word count program. So let me take certain input, word count program, or boring words, or post analytics, or small. Okay, so it is good to I can move with this particular uh, text file, word count program. Let me try to copy and paste it in new folder. I'm going to create a new folder and say word count, and I can paste it over here. And let me copy this particular path and paste it over here. This is the input source where the data is stored. So over here, friends, we just need to mention the directory. We just need to mention the directory of input source. So I have used the forward slash at this moment, single forward or double backward slash, in order to have the input. And this particular directory I'm going to utilize in order to read the data. So what I'm having, say I am having a particular lines, and lines, that is spark dot read stream. Previously we were using standard read API. Now what we are having, Spark stream, stream read API. Read stream. So I'm going to read the streams. Then format is of, say what? Format is of text type. Format is text, and option, and I need to mention the path. The path, and this particular path is nothing but input source. This is the path for this particular file. Input source and dot load. So I will be able to load this particular data. Now, let me check this particular data is a streaming data or not. Let me try to check. So we are having a particular function print and say lines dot is streaming. So is it a streaming, you can say, data frame or not? Let me try to do the execution. Current file and just have a look. So the execution has been started, and so certain warnings are there. We are not bothered about the warnings. Okay, so this particular data, what we have read from this particular source is of streaming type. Is lines is stream, so this is of streaming type. So this particular data frame is of streaming type. Let me try to print the type of lines. What is the type of lines? So that is nothing but data frame. So this particular data frame is a streaming data frame, what I want to say. So we have created a streaming data frame based upon this particular data. Okay. And now what I want to do, I want to calculate the frequency of each and every word in this particular data. And then I will show you how the streaming will work over here and what will be the outcome like during the streaming context. So this is the data what I'm having over here. Now what I need to do, I need to, these are the lines basically. So I need to convert line into say words, and for this what I'm going to do, lines dot select. So I'm going to select these particular lines, and what I'm going to do, I'm going to explode lines, explode lines, lines dot say values. I'm going to explode based upon values and based upon what space. So I'm going to explode the lines based upon space, and I'm going to give alias as a word. So I'm going to convert into words. Okay. So what I have done, what I have done, I am having say lines, and I have exploded lines basically based upon the space. Say this is a particular line over here. How are you? Okay, this is a line and let us say in this particular way. Okay, I'm having this particular line, and if I'm going to apply explode and splitting it, so it will be converted in this particular way. How explode based upon say explode based upon space. Okay, exploding based upon space. How are you? Comma are comma you. Okay, it will be converted into this particular, earlier it was in this particular form. So I have exploded the data in order to convert into words. Now what I'm having array of words. This is array of string. Now I'm having array of words. So this is the array of words. Now what I can do, I can group by onto these particular words, and then I will be able to calculate the count. If I'm going to group it, if I'm going to apply group by and then count, then I will be able to get the count. So how I will be able to do, say word count equal to, so words dot group by, and group by based upon word, based upon this particular word, group by word. And I want to have the aggregation, say count, and say star star, count star, and I'm going to give say alias, and alias I can give say count, total counter count. I can have this way. Okay, so this is the way in order to say apply count onto each and every word. And what I have done, I have applied the, because with the help of group by and count, this is simple, you can say aggregation function. Now I just want to you can say visualize it onto the console. So write API, so query equal to, so word count dot write stream, and then what I can mention dot output mode, I can mention the complete, then format, in which format I want to have, so dot format, and format I want to have console. Over here I just want to display the result inside the console, and dot start, and I just wait for the termination, dot await termination. Okay, so let me write something before the execution of this particular code. So Spark streaming application, when a Spark streaming application will stop. So the Spark streaming application are meant to work for forever. So application are designed to work for forever, but the application can be stopped in two ways. The applications can be stopped in two ways. First, some error occurs. Second, stopped by programmer or developer. So Spark applications are will be continuously running until unless it is not stopped by the developer or some errors are occurred. Okay, so this particular application will keep on executing. Just have a look. So what we have done, we have written a particular simple program to calculate the frequency of each and every word, and let me do the execution. So the execution has been started for this particular program. certain warnings are there. What has happened? Explode take one positional argument, but two were given. Explode. Just a minute. Okay, explode split. So what we need to do? Split lines based upon value. Explode split lines, and then I can close this. Okay. Okay, I need to do splitting based upon the space, and then I'm going to explode it. Okay, fine. Let me do the execution once again. Explode split. The execution has been started. It is providing me the outcome true. This is a particular streaming data frame. Now it is keep on going. It is in execution state. We will be going through with checkpointing and all. What is this particular checkpointing? And no need to worry. Now soon the batch 0 will be there. Post calculation of the frequency of each and every word. Based upon this particular logic what we have written, we will be having the outcome as batch 0. Just have a look. So you how is data is hello big 9. So what we are able to get? We are able to get the frequency of each and every word. This particular program keep on executing. Let me create a copy of words program. I have created another copy. You can think in this particular way. This is a particular path where we are continuously we are getting the new files. So big 9 is there. This is batch 0. Soon we will be having batch 1, and at that moment we will be having the updated values. Okay. So the calculation will happen based upon the data what we are having in this particular directory, and then we will be able to get the outcome. Okay, this is batch 0. Just have a look. Batch 0, and soon we will be having batch 1, another batch, post calculation of the frequency of each and every word, or based upon the logic what we have written in our code. So big 9 is there. Soon it will be big 18 in batch 1. Okay, so batch 1 is there, and then big 18 is there. Big 18 is there. Now what I can do, I can have another copy of this particular batch, another copy of this particular word count program file, and those particular things will be added, and in batch 2 I will be able to get the updated values. Now in this particular way you just try to think the example what I have quoted. Like say if someone is going to do the analysis of a particular minister's speech or conversation, then whatever he or she is speaking, they the reporter will be able to do the analysis. So so he will be able to add all the words over here we are having certain bogus words, say to, or, it, is, how, you. So these are nothing but bogus words. Those are required in order to complete the sentence. So we will be able to filter those particular bogus words as well. So we can do the analysis onto that particular level as well. This is batch 1. Inside the batch 2 we will be having, just have a look. Now we are having the batch 2 information. Batch 2, and all of the words are clubbed together, and I'm able to get the outcome. So this is the beauty of streaming, and this particular application is awaiting termination. Query.await termination. It is, the application will be keep on going until unless I'm not going to stop this particular application, or certain errors are not occurred. Errors, say if I'm going to open a particular file. So say I have opened this particular file, and it will throw certain error. It is going to say, let me do the copy, and the execution is being happening. I have opened this particular file, and probably it will throw certain errors. So the execution is keep on going. And what we are having, we are having batch 3, and those particular files are there, and the records has been updated. And now what we have added hello as well. We have added hello with small letters. Certain updation is there in a particular file, batch 3, and let me try to delete. So this particular application still in execution state. And let me close this. We are waiting for batch 4. batch 4. So batch 4 will come soon. This is batch 3. The application is still in execution state. We should get the information. Let me stop this and do the execution once again. Let me remove this particular copy and start the execution once again. Just a minute. Let me reduce the time as well. Okay. So I have started the execution once again. I have started the execution once again. We got the input with respect to true, and this is a data frame basically. And soon we will be able to get the batch 0. Batch 0. Certain warnings are there. temporary checkpointing location created which is deleted normally when the query did not fail. Checkpointing is a methodology in order to handle late data handling. So first batch is there, batch uh, 1, batch 0 basically. Let me try to say copy and get the batch 2 as well. So this is batch 0. I'm waiting for another batch. And hello, is hello there? Hello, so it has not taken the words, huh? Okay, this is not updated as well, huh? Hello is not there, huh? What we have typed. So soon we will be able to get the batch 1. This is batch 0. We are waiting for batch 1. So batch 1 is there. Now let me delete 1 and what is happening, huh? And type and put another, you can say, text file over here. New, how are you? How are you? Okay. Another file is there with the name how are you. So how to is there and we are expecting say how to and hello with small one small h. Just have a look. We are waiting for the updation of this particular data. One new file is there. So inside batch 2, what we will get? We will get the updated information. Okay. So this is the batch 2. And in batch 2, what we got, how to is there. That is fine, how to. And are you? How are you? R2. But just think for a minute. What I want to say over here, say you are having file 1. Okay, file 1, batch is running, say batch 0, and file 1 is having certain data, and let me mention over here. So file 1 is there. File based upon the data we are having, we got the information in batch 0. Okay, so then what we are having, we are having file 2, and then calculation is happening, and we are getting say information in batch 1. Try to focus what I want to say over here. Then what we are having, we are having file 3, and inside the batch 3 we are getting the cumulative information of file 1, 2 and 3 in batch 3. Now what we have done over here, say we have removed these two files and we have inserted another file with name say ABC. So what it will do, whatever the data is available over here, it is going to add that particular data with respect to new file. Say over here ABC file is there, abc.txt is there. So abc.txt, so it is not going to, you can say, delete. Just have a look over here. What we are able to see, we are able to get the input with respect to what we have accumulated so far with respect to these particular files. Say file 1, file 2 and file 3, we are having certain result. Now file 1 and file 2 and 3 has been removed. So it is not like say data will be updated. Data is not updated because what we have used over here, we have used the complete mode. We have used the complete mode. Complete mode is going to, you can say, add in the previous result. Now, what I want to say over here, inside the Spark streaming world, there are two types of transformation. Streaming transformation. So, streaming transformations, say stateful transformation and stateless transformation. Stateful transformation and stateless transformation. So, over here, result will depend on previous execution. Okay, result will not depend on previous execution. What is the meaning of this? Will not depend on. Okay, inside the batch processing, say if we are calculating the sum of or if we are calculating the frequency of each and every word, is it dependent on to any previous execution? In batch processing, is it dependent on to any another previous execution? Batch processing, or
No,
once we
sir.
have done the calculation in Dataframe or SparkSQL, is the result dependent on to any other previous execution? Say yes or no. In Dataframe or SparkSQL, is the result depending on previous execution? Let me try to elaborate more. So what we are having this particular data frame. So we are having this program, and in this particular program, what we are doing, we are calculating, we are converting certain date into different format with the help of regex and all. With the help of certain functions, we are converting the date from one format to another format. So let me do the execution. Stop day 14. Okay, so the execution has been started at this moment. The execution has been started, and we will be able to get the outcome. So this is the outcome, say, with respect to this particular execution. Is this particular outcome was depending on to any other previous execution?
No, sir.
Rohit, Swati. Okay, so that's what I want to hear. Like inside the stateless transformation, the execution is not dependent on to the previous execution. But over here inside the stateful transformation, say once we are having file 1, okay, and we got the outcome inside the batch 0 with respect to file 1. Then we are having file 2. Then again the execution, it is like continuously running. It is going to do the calculation. It is going to check the check pointing directory, and from the check pointing directory it is going to take the outcome of file 1, and it is going to add with respect to file 2, and I will get the outcome in batch 1. Okay, So this is the stuff inside the streaming data processing. Streaming data processing is happening inside the stateful transformations. We are going to maintain the state of execution. Okay, and if like state is not maintained, then say we are you can take this particular example. We are having this particular 18K counters, and say we are getting the data at every, you can say, 1 minute from each and every counter. So we are able to get the input with respect to say what is the sale in last 2 minutes. Okay, every 2 minutes we are getting the result or information. So we are able to get the status like what is the sale in last 2 minutes. But if I want to do the calculation of if I want to do the calculation of last, you can say 30 minutes, then what I need to do, I need to do the accumulation of last 15 row. Okay, I just need to do the calculation of on last 15, you can say, transactions what I have received. Okay, or what I can do if I'm having this particular KPI, like I need to monitor every 30 minutes, so I can create a KPI, or I can formulate a KPI what is going to, you can say, take the data of every, you can say, 2 minutes, and it is going to do the sum, and based upon that I will be able to get the updated outcome. So over here what I'm going to do, I'm going to maintain the state. Okay, like what is the value of last you can say 28 minute. Now again new 2 minutes has been added, and I will be able to get the window of 30 minute. So streaming transformations are stateful transformation. Over here I need to store the result. Okay, so that the new value which is coming based upon the new calculation, that will be accommodated over here, and I will be able to get the final result. It is not like, say, if one team is playing, if two batsmen are playing, and I just want to ask the score, then it is the accumulated score of entire team. It is not like, say, the score of two players only who are batting on the crease. So the same thing is happening inside the streaming world as well. Streaming world, or a world, is having stateful transformation. One state is dependent onto the previous state, and that's what we have seen over here. Like if we got the outcome of this particular state, if we got the outcome of first state, then it is dependent onto the 0th batch. If we are getting the result of in second batch, so that is dependent onto the batch 0, batch 1, and cumulatively for batch 2 as well. So that is the way of, you can say, data handling or data processing inside the streaming world. Just have a look and ask if you are having any doubt. Just have a look onto this particular code. Any doubt, any confusion, anything that you want to ask? Anything you want to ask? Shivam, Naresh, Raj, Rohit, Swati, Rahul. Any
Uh,
confusion?
can you
No
slide
confusion,
slide?
but can you just show
Can you
once
slide
like
your
how you have terminated the streaming?
Mm-hmm. I'm not able to hear properly. Speak one by one.
Can you please slide it up?
Slide.
Just scroll it up.
Uh-huh.
Not here. In a code. In a code.
Okay. Hmm.
So here the line in line 10. it is mentioned like SSC is equal to streaming context.
That is Spark
But
streaming context.
so where does we use this in this code?
Spark streaming context is we have imported over here.
Okay. In below mentioned code, anywhere we are mentioning this type.
Actually, like once you have created this Spark context, okay. So over here, just have a look. Spark dot read stream. Read stream is possible with the help of Spark streaming context only.
Okay. Okay, got it. Actually,
Okay,
this is the line. It is
and
confused.
once read stream is there, then entire you can say mechanism will change.
Apart of it, I don't have any questions.
Okay,
I'm okay.
not an issue. What you want to ask, Swati?
So I just missed one point, like where you have terminated the execution. How you have done that? Please show once again.
Termination, just stop the execution over here. What I have already mentioned over here. Streaming jobs will not stop. There are two methods only in order to stop the job. Like if some errors are occurring, or if you stopped it, stop that particular job. Streaming jobs will run for forever.
So that I know, that I got the point. Like you have simply stopped the execution from the top. There is no command for it. Like for in real time, how it is working in companies. Like one of the project of my company is a streaming job. There it gets stopped because of error itself. If anyone wants to stop it, otherwise, then how they will stop?
Okay. So basically, like they need to kill that particular application. They need to kill. We are having, say, if they are
Okay, like we what
yarn
yarn
kill.
application
Yes, yes,
command we have. Okay,
yes,
thank you.
yes. Okay, for this particular application, we will be having a yarn idea, and with the help of that particular yarn ID, we will be able to kill that particular application. I will show you once we will be creating an EMR cluster. Over there, we will be going through with those yarn commands as well, like how to list the different applications which are running inside the cluster. Okay, how to pick a particular applications and stop that particular application. It might be happening, say, all of your resources has been utilized by one application, and that application is in locked state. That is not, you can say, completed. So what you need to do, if like all the resources has been occupied one application, then definitely you need to proceed to stop that particular application. That is hard stop basically. Okay, you need to kill that particular application. You will be able to see like how many resources are being, you can say, utilized by an application. Okay, memory core. In organization, what is happening, Swati and team, basically, uh, we are having certain monitoring tools. Okay, with the help of monitoring tools, we will be able to do the analysis based upon the application level, based upon the cluster level, or based upon resources level, like how many cores has been utilized, and what is the the usage of core, what is the usage of memory, what is the usage of machines in this particular cluster. So with the help of those particular, you can say, analysis, we will be able to scale up or scale down our cluster. You probably you have seen certain lines in some resume, like I have saved this much of cost. So that is possible because of like either that particular person has done the optimization on to top of certain jobs, like certain optimization has been applied. It might be, say, resource has been minimized, or certain optimization technique has been applied. Or it might be possible, like there are certain applications which are running infinitely. Okay, and nobody is bothered about those particular application. And in the cloud world, the charges are based upon usage. If some applications are in running state and there is no outcome with respect to those particular application, then definitely the organization need to bear some cost, need to pay certain cost. So that particular analysis is also required in order to minimize the cost, and based upon such analysis, um, probably like say the old organizations, if I can say TCS or say IBM, these organizations are having certain applications, and say some persons has created or drafted those particular applications, and they have executed started the execution of those application. Now team has been changed, but those particular applications are still in running state, so certain audits are being happening. Some uh, people are going to identify like these applications are bogus, they are not providing any output, or whatever they are these applications are providing, that is of no use. So better try to kill or stop these applications and provide the resources of these application to the another one. So in this particular way, like you will be able to minimize the cost, these particular analysis are being happening in the software field. Okay, so you need to kill the application basically. Okay, so this is say the batch zero outcome, and the application will keep on running, and until unless I'm not stopping, it will not be stopped, or some errors are not occurring, it will keep on running state. This is the beauty of Spark streaming. Okay, this is say first example of word count. Now you can take it in this particular way. You can take it in an exam, or you can take it an assignment. So we are having this particular data. We are having this particular flights data. Okay, inside the flights data, what we are having? We are having planes information. Let me try to show you. Okay, in this particular data, what we are having year, month, day, departure time, departure delay, arrival delay, carrier, tail number. So such type of, you can say, data is there in this particular small flights, flights underscore small file. Now what I want from your side, over here arrival delay is there, and tail number is there. So what you need to do, you need to do the group by based upon the tail number. Or what I want the delay, arrival delay of each and every flight, arrival delay of each and every flight, and I want top 5 flights which are having highest delay in descending order. Okay, I want this one. And so again then that particular, you can do the calculation based upon the Spark data frame. Then what I want, you need to do it with the help of Spark streaming. Okay, so once you are going to perform the analysis of this particular file based upon Spark streaming, in Spark streaming, okay, once you are dealing with data frame, or once you try to read the data from a particular file, so you need to utilize file stream. You need to utilize file stream. So you need to read from that particular location. Okay, file stream or read stream, the thing is same. So format, that will be CSV. And after reading this particular stream data, what you need to do, you need to do the aggregation, or you need to do the group by based upon the tail num, and then you can say count or aggregation sum of this particular arrival delay, and you need to short it descending. You need to do this, but before you can say reading this particular data, you need to define the schema. Inside the Spark streaming world, infer schema will not work. So either you need to define it with the help of struct field, or you can say programmatically defining the schema, or you can utilize the string objects in order to define the schema. So first define the schema, then read the data, do the aggregation, and then do the calculation. So rest this particular code will remain same over there as well. Okay, the code what you are able to see over here, this particular code will remain same. Like reading, that will remain same. You need to do a certain change like group by based upon tail number, and then aggregation based upon the arrival delay. Short this based upon the arrival delay, and then you will be able to get the outcome. You need to write the outcome onto the console and query.await termination. So the code will be quite simple. You just need to share it by EOB, today's EOB, and try to run it first, and you will be able to get the outcome. And once you got the outcome, try to share the code onto the WhatsApp channel only. Yeah. So that take this particular thing as an assignment. Now, what I want to say over here, we are having stateful transformation and stateless transformation. Now inside the Spark streaming, we are having a source, data source, basically data source, data source. So what we are having file source, we are having Kafka source, we are having uh, socket source, and we are having rate source as well. Socket and rate source, these are meant for the testing purpose only. File source we have already utilized, like reading the file of from a particular location. Kafka source, over here, like Kafka is being, you can say, utilized in order to provide you the live streams of the data. And inside the Kafka, we are having Kafka producer, Kafka topic, and Kafka consumer. So those particular methodologies are there, which are being utilized in order to, you can say, publish the record. Uh, and those particular records will be processed with the help of Spark streaming. So tomorrow we are going to cover the socket source and how to deal with socket source. Kafka, like I will show you the connectivity, how to connect with Kafka, and then we will be able to read the data, and we will be able to process the data. Okay, so these are the things with respect to the data source. In the same format, like we are having sync. Okay, sync, like writing the data onto a particular location, writing data or output, basically output on a particular location. Location. Okay, so rest of the thing, like we will start from the sync, and then we will move further in today's session, tomorrow's session. So that's it for this particular session, and tomorrow we will start from the sync, and I will start AWS, and then club it with Databricks. Rest of the stuff, like we will be doing onto the AWS and Databricks. Enough for the you can say local processing perspective. Rest of the stuff we will be, you can say, doing onto the cloud only. Yes, in tomorrow's session we will be having certain stuff from the cloud side, and the socket source and other stuff, like the remaining practical onto the streaming side, we will be doing onto the onto the cloud environment. So that's it for this particular session. Let me stop recording, and if you are having any doubt, you can ask.